So other radical equations, we're going to see square root, like we see down here. And then we're also going to see ones that have rational exponents. So maybe x minus 2 to the 2/3 power equals 5. Alright, we're going to be solving for x. So the warm-up asks you to solve by factoring these are all quadratic. So what would I do first if I'm solving by factoring these factors? We'll add x and subtract 6 to both sides so that it is in standard form, which means it's in the form ax squared plus bx plus c equals 0. Then we would factor, right? So what would this factor into? Plus 3 and x minus 2. Very good. And then remember, the direction tells us to solve by factoring. It did not just say factor. So from here, we use our zero product property and we set each is equal to 0. And we solve to get x equals -3 is 1 answer. And the other one, we add 2 to both sides to get 2. Alright, how about number 2? We're talking about number 2. Very good. And we would subtract. We like to have a positive x squared when factoring. That's the reason that we don't move the x squared over. Technically, we could do it that way because it works. It makes fractions a little bit. And then we did have our -7 and our 2. And then how about number 3? Yeah. Very nice. So this one was our Dutton factoring back from chapter 5. Because the a value is not 1, it's 2, that's when we contact the Dutton factoring. Okay? So we could start out with our 2x and our x. We know that's the only option. And you come up to say around you're putting 3 here is positive or negative. So we could have a positive 3 here and a -1 there. That will remember we charge our FOIL. We will get 3x and a negative 3x is going to be x. And then due to use the zero product property, we subtract 3 and divide by 2 to get negative and x. So today we're going to be looking at some of the simpler equations. Tomorrow we'll actually be using the fraction within the solver. Because sometimes you want to be doing like that there and then have to FOIL and then also factor. So the vocabulary is actually typed out for us then. As a radical equation is an equation that has a variable and a radical. Which if you remember, the radical means under the radical. So the variable has to be under a square root or a cube root. So for example, 5 equals 2 plus the square root of 3x. That would be a radical equation because the variable x is under the radical. If x is out here, we know that's under the radical and it's not actually out. So I have some steps typed out to solve these, but you are basically using inverse operations for the most part. So step 1 is going to be to isolate the radical on one side of the equation. So we want to get the radical by itself. I use inverse operations to make this fit by adding 6 to both sides. It says to raise both sides of the equation to the appropriate value. What that means is we're going to undo a square root with square it. We'll undo a cube root with cube it. A fifth root with equal parts out. So since this is the square root, I would square both sides. Because squaring and square rooting are inverse operations. So these are really going to undo one another. Leaving you just with what's under the radical. The radical is 5x plus 1. On the other side, 6 squared is 36. And then now you just pull 2 plus 2. Subtract and divide. and we'll get our answer, which is x equals 7. Sometimes we will get more than one answer. In the back, we'll see that a little bit more. Now, we should check these. Since we are on a modified fall schedule, we're not going to do all of them. We're kind of but you would want to check tomorrow. Sections will actually say solve and check for extreme solutions. So tomorrow, you may get two answers. One will not for this problem. But whenever you check, you want to make sure that you are putting in the original. So I'll check this one and then we'll check the other. So you would end up doing 35 plus 1 is 36. The square root of 36 is 6. 6 minus 6 is 0. Number 2, very similar. What are we going to do first? And good. Isolate by adding 10 to both sides. And then we will square both sides. I don't think they have any on the homework, but technically they were too easy to and then it's just simple solving. Subtract and divide. And if you would have time on a figure calculator, the word problem. The one that I have in the notes is not that difficult. There are two in your homework tonight. One of them is actually kind of challenging. Those of you that took geometry may understand a little better than those of you that didn't. So it's number 14, says develop understanding of the one of the things that makes it hard is that you'll actually need to modify the equation using the video. Also, I have still got the problem out in the video, so I'm going to questions. The problem in the homework will say, and this is the one I need. So just be careful that you do. That's number 14 if you want to jot it down. Just to keep an eye out for that, the unit in that. The one I did in the notes is too challenging. It tells us the power P in watts. So P is our power. That a circular solar cell produces. And the radius of the cell is in centimeters. And these are related by a square root equation are equal to square root of 2 divided by 2 times pi. How much power is produced by a cell with a radius of 20? So we're going to use 20 is and plug it in for r radius. So we'll have 20 equals the square root of p divided by 0.02 pi. Let me just have to solve for p. So normally we would isolate that off square roots, but it's already isolated. So we can go straight to squaring both sides. We'll get 400 equals p over 0.02 pi. Now how would I solve for p from here? Division, and the inverse of dividing is to multiply. If we were to leave it in terms of pi, we would just multiply the 400 and the 0.02 with each pi. Those two that did take geometry, we know that a lot of people left in the pi. But I think the book will have me round in there to so the direction. So we would just type in our 8 and our 5 to the calculator, and we should get 25.1. Now we want units on that. What would our units be? Yeah. You see? Watts. So be careful, solve for P, and P was in watts. The radius is what was in here. Alright, on the back we're going to see exponential form instead of radical form. So you'll see the equations are going to be really similar, but instead of seeing a square root or a cube root, you're going to see that exponent. That is a rational. So the steps are pretty much the same. We're going to isolate the variable or the quantity on one side. However, instead of just excluding and squaring, we're going to raise the equation on both sides to the reciprocal power. So what it's going to do is it's going to help eliminate that exponent. So for example, if I had x to the 3/4 and I wanted to get rid of the exponent, I would have to raise this to the reciprocal power, which is 4/3. The reason that this works is that when we raise a power to a power, we multiply, right? So you get 3 times 4, which is 12, and 4 times 3, which is 12, and 12 over 12 equals x squared, which is just x. So when we're doing the equations, the only thing different is that we're going to raise both sides to the reciprocal power, instead of just one side, and we will simplify. Now, one thing we have to remember, so some stars here. Back in section 1.1, we talked about even roots versus odd roots. So whenever you are taking an even root, so for example, if you have x to the 4th equals 16. If you were asked to solve that, you could take the 4th root of both sides, which is an even root. If you were to type this in your calculator will tell you 2, but that is not what the answer says. It's technically positive and negative 2. Again, the reason that the positive and negative are necessary is because we added in this 4th root on our own. Okay, we didn't have it for us. And technically, positive 2 to the 4th and negative 2 to the 4th is the answer. So just be careful that if you have an even root that you do attach your positive or negative. When you have an odd root, you don't have to do that, right? Because the cube root of, let's say, 27 is just 3, not positive. So you just have to check if you're giving the cube. So some of these are going to get standard instead of 1. So for number 2, wanted to isolate the variables. We're actually going to isolate the whole quantity, x plus 3. So I would need to get rid of the 2 up front, which is being multiplied, so I will divide using its inverse operation. And this is when I'm going to use my reciprocal power. Now, some students like to put another set of parentheses. I like to put brackets personally, just because they stand out a little bit more, but you need something to group it off, and then we are going to raise it to the reciprocal power, which would be the 2/3 power. And again, what that does is eliminate the exponent. So you're going to get 6 over 6, which is 1. Or you could also think that these are going to cross cancel or cross reduce. You're left with just x plus 3. Now on the other side, you have to do a little bit of work. I wouldn't be relying on the calculator because you're going to calculate and give you one answer. Sometimes there is only one answer, this is an answer out of 2. So I would probably do the work for this off to the side. So the denominator is our root. So this is the cube root of 27. Now instead of squaring the 27, I don't know what 27 squared is, I would square the quantity. Now with on your last test, some of you were always trying to say the number when you have to use your calculator. Try to get away from them if you can. So the cube root of 27 is just 3, because that's an odd root. And then 3 squared is 9. So I won't have a plus or minus with this one because it's simply odd. And then we solve for x. So subtract 3 and we get x plus 6. We would actually, yeah, if it were an even root, which is we would actually put more into the next one. We'll put a positive or a negative right here. Then you'll square the positive and the negative. Or apply whatever operation. So it's going to be attached to whatever you got in the set. It would be not necessarily. Sometimes it happens. So the next one, we will isolate this as x this time. We would add 5 to both sides to get 16. And we'll divide by 4. sides to the reciprocal power, which is our 3/2 power, to get just x equals, and off to the side, I'll do the work for this. If the denominator of 2 plus the square root of 4 quantity cubed. So right here, this is what Andrew's asking about. When you take the square root of 4 and you want to jot down if that's a positive or a negative 2, like being cubed. Well, positive 2 cubed is 8, but negative 2 cubed is negative 8. Your two answers, x equals 8, and x equals negative. Now, I would like to get to number 6 because the answer does have a positive and negative, but the answers are different. That's because it has a parentheses. So for this one down here, we would add our 4 to get 9. Then we'll raise both sides to the reciprocal power, which is our 3/2. So we'll be left with x minus 2. Now on this side, again, we take the square root of 9 quantity cubed. The square root of 9 is really positive and negative 3. And then you're cubing positive 3 and you're cubing negative 3. So that's going to get me positive 27 and negative 27. Those aren't my answers though. Those are what goes in on this side of the equation. So but plus or minus 27. But now x isn't solved for you. You actually need to probably put up 2 separate equations from here. One where x minus 2 equals a positive 27, and one where x minus 2 equals a negative 27. Solve each one. So we'll get two answers. One of them is 29, and the other will be negative 25. Okay? You are only completing the 1 through 14. So when you follow my teacher page, you're going to see 1 through 30. You're only doing 1 through 14 today. Alright, tomorrow we'll do the rest after we complete the notes. The last example here that we have, we would be solving for x. First, isolating our x plus 1. We would undo our multiplication of 3 with division of 3. And last, we will go ahead and raise both sides to the reciprocal power of 5/3. Again, these will undo one another to become x plus 1. On this side, we probably want to do some work off to the side. We're taking the cube root of 8 and then raising that to the 5th power. The cube root of 8, this is an odd root, so the answer is just 2. Not positive or negative 2, just 2. And we all know 2 to the 5th power is 32. So last but not least, we would then solve for x using our inverse operation to get x equals 1. Again, the homework is numbers 1 through 14. Be careful with number 14 to pay attention to units. I believe the whole problem is in feet, and they ask you to round to the nearest inch. So you want to make sure you convert that at the very end.